Metal casting covers a wide range of processes. For this very large ferrous casting, the most appropriate method is the pit moulding technique. For metals that melt at temperatures greater than 1000 Celsius, for particularly intricate or complex shapes, and for materials that are difficult to machine, investment casting could be the best choice. When only a few hundred units are required, moulds made by the cold box or green sand method would be appropriate. In mass production situations, particularly where aluminium, zinc, magnesium and brass are to be cast, a die casting process may be the most effective way of making quality castings at minimum cost. Gravity die casting, also called permanent mould casting, is used to produce castings in medium quantities, castings requiring maximum internal integrity, or castings that require heat treatment. The process is also used for very large numbers of castings that have complex internal shapes requiring the use of cores. The main parts of the die are risers, down sprue, die block and its movable parts, ingates and dross trap. In this casting, sand cores are set into the die. Molten metal is poured into the pouring basin, enters the runner system, fills the die, cools and solidifies. The die opens and the now solid casting is removed. Cores are added and the die closes, ready for the cycle to recommence. The cores can produce a simple hole in a casting or a complex cavity. They are made from a bonded sand, and a new set of cores is required for every casting produced. The most commonly used alloy in gravity die casting is the aluminium-silicon-magnesium alloy, as it has good castability and good mechanical properties. The metal generally takes 1 to 4 minutes to solidify. These risers feed the casting with molten metal. Ceramic die coats are sprayed onto the die, and these will help control the rate of heat transfer within the die.